All right, today we're going to talk about the three forms of the equation for quadratic. So quadratics have three forms: the standard form, the factor form, and the vertex form. They're all used for different purposes. The one you should be most accustomed to seeing is the standard form. That's the form they're usually going to give it to you in: ax squared plus bx plus c. It tells you here where a does not equal 0 because we do have to have that x squared term in order for it to be a quadratic. There's the factored form, which is the one that's created when we factor that standard form, and it is a times x minus r1, x minus r2. That r1 and r2 stand for the roots. So that's x minus my first root, x minus my second root. And then there's the vertex form, and we've seen that one. It's very similar to the transformational form. It gives us the vertex, so that's why it's called the vertex form. In fact, each one of these equations give us different pieces of information. You're going to want to know these three. You should be able to identify which form it's in when it's given to you, and then you're going to have to be able to identify what parts it gives us. So some of the characteristics of quadratics that we've talked about are x-intercepts, y-intercepts, the vertex, the axis of symmetry, and concave up and down. These attributes can be taken from those equations. So we're going to talk about what each form gives you. And so we've said the concavity is up or down, which way the parabola opens. So that's defined for you there as well. But we're going to talk about what these three forms of the equation characteristics, which one each gives you. So our standard form, which is the y equals ax squared plus bx plus c, that's the one the calculator gives you when you do regression, and it's usually the one that's given to you to factor. This one doesn't give you as much key attributes as the others for graphing purposes, but it does give us the y-intercept. This part right here is the y-intercept. So 0c is the y-intercept. And then it also gives us the concavity, whether it opens up or down. If the a value is positive, it is going to open up. If the a value is negative, it is going to open down. Those are the two big pieces of information that, looking at the standard form, you can get those key attributes from. Our factored form we talked about was the y equals a times x minus r1, x minus r2. This is my first root and my second root. So it gives us the roots. Or we've talked about, they are also called the x-intercepts. So our roots or our x-intercepts are given by this form. It is r1, 0 and r2, 0. Those would be our x-intercepts. It also gives us the concavity because it too has that a value in the front. And so with the positive a, it's going to open up. With the negative a, it is going to open down. The last form up there is the vertex form. This looks really close to the transformational form. The difference is that this is called h and k for some reason with quadratics, because that's our vertex. When it's in that transformational form that we saw last class, you will see that c and d are the vertex as well. So the form is pretty much the same. This too gives us the concavity because it has the a value. So a positive a value is up, a negative a value is down. But it also gives you the vertex, which is a huge part. This part right here, that h and k is your vertex. So just by looking at the equation, you should be able to see what the vertex is. It is h is the x value, k is the y value of your vertex. And if it gives you the vertex, then it's also giving you the axis of symmetry, because the axis of symmetry always cuts through the vertex, and we said it's going to be a vertical line with these up and down parabolas. So that is x equals h. Now you are able to get all of the information anyway, regardless of the form that they give you. That's just the easy information to pull from it. So we're going to look at some examples and just show you how to get each one of the attributes from each form. So we're going to start with the standard form here, and I've chosen a couple equations and their matching graphs so that we can look at that. We said the standard form gives us the y-intercept. It's that c value. So we've got the c value here of 21, and you will see that it crosses the y-axis there at 21. This one has a -1 for the c value, and we see it crosses there at -1. And this one's got a 5.5, and we see it crosses the y-axis there at 5.5. So the y-intercept is that c value. So in this case, that's 0c is the y-intercept. We also said it gives you the concavity. So this a value is negative, so we've got a downward parabola. This one is positive, so we've got an upward parabola. Positive, so it's got an upward parabola again. So positive a, up, negative a, down. So it gives us that concavity as well. Now for the other parts, because you still should have to get the other parts, or you will be asked for the other parts given that standard form. There is a formula here for the axis of symmetry that is -b/2a. And it's not quite another formula for you to remember, because if you know the quadratic formula, this is the front part of that quadratic formula. Remember that -b plus or minus the square root of b squared minus 4ac all over 2a. Well, this is that first part, the -b/2a. So you're not remembering another formula, it's just part of that one. Or it's x equals h, so if you get the vertex, you would also get the axis of symmetry. To find the places where it crosses the x-intercepts, or the roots, you can just factor. So we've practiced factoring quite a bit, so factor it, and that would give you your roots. You also have the option of doing it in the calculator. You can put the equation into y1, and you can put 0 into y2 and find the intersection. Or if you use Desmos, then that would also give you the intersections there by putting it in. To find the vertex, well, if you found the axis of symmetry here, then you already know what the x value is. It is -b/2a. You would take that and plug it back into the equation and find its corresponding y value, and that would be your vertex. All right, the next form we're going to look at is our factored form. In the factored form, we have here, there's the formula again for you. We've got the factored forms here and their matching graphs. So we said with the factored form, it gives you the roots. So those two values right there are the same ones as the ones here. This one is 3 on both of these, and there it is at 3. And this one has a -5 and a +1. Notice that it is not quite intuitive. Because it's x minus the root, then the minus is part of the formula. So 3 is the root here because that minus is part of the formula. When it changes signs, then we know that was minus a -1. So -1 would be the root that goes here. See that -1? Same thing here. This was a minus -5, so that -5 goes on the other side there. So our factored form gives us our roots. So that's r1, 0 and r2, 0. It also gives us the concavity. Again, when it's positive, it's going to open upward. When it's negative, it's going to open downward. We still have to be able to get the other parts, even though it doesn't give it to you just by looking at the equation. You can do a little bit of work to get them. Back in geometry, you learned the midpoint formula. So our vertex has to be in the middle of these two right here. Because of the symmetry on a quadratic, so we've got these two roots right here, the axis of symmetry would have to cut right through the middle. So if I use my midpoint formula, I can find it. So I used my roots to find that midpoint. And that would be my axis of symmetry. Remember, if you have the axis of symmetry, you also have the vertex x value. So that would be my x value. And to find its corresponding y value, we would just plug it in. Then for the y-intercept, we plug in 0 for the x and solve for the y. which in this case is easy because when you plug in the 0 for the x here, that's going to make it just simple math to finish that part. All right, our last form here is the vertex form. That's this formula right here. Again, you've got to know those three forms. You should be able to identify them, and you should be able to identify the key attributes it gives you. And so we're looking at three of the vertex form right here and what their graphs, their corresponding graphs look like. So we said the vertex form gives you the vertex. That's right here and right here. So this would be -2 and -4. Again, that minus is part of the formula, so this would be minus a -2. So our C or H value would be -2, and then our K would be -4. And so -2, -4 is right there. That's the vertex. 4, -2 would be the vertex here, and there it is at 4, -2. And then this one doesn't have anything written there, so that's 1 and 0. There's our vertex right there. So our formula gives us the vertex. So this is H comma K. If it is giving us the vertex, it is giving us the axis of symmetry. That axis of symmetry always cuts through the vertex. So it is x equals, because it's a vertical line, and the x value of the vertex that it's going through. For the concavity, again, if it's positive a, then it's going to go up, and negative a is going to go down. To find the x-intercepts, you can plug in 0 for the y and solve for x. Or again, you can put them in the calculator and find the intersection with the TI-84, or in Desmos, you can find the roots by clicking on them. For the y-intercept, we plug in 0 for our x and solve. And again, that's the easier one because you're plugging 0 in right here, and then it just makes it basic math. Or you can go to the table on the calculator where x is 0, and that will give you the y. So it doesn't matter which form they give you, you can still manage to get the information needed from the form. You guys are going to be given all three forms and asked different questions, and we're going to continue to work with the three forms of the equations, but here was the basic introduction to the three forms, what they look like on a graph from the equation, and then again, what parts you could get from it. If you learn that there is different ways that you can help yourself eliminate answer choices on a test or a quiz, or even on as you're thinking through these. So given this graph right here, it doesn't have any numbers, but we can eliminate some of the choices just by seeing some of the parts. So when I look at this first one, I see this is the factored form. Again, you have to be able to identify this. So this is the factored form. The factored form gives us our roots. And so the roots for this one would be -1 and -4. These are both negative roots right here, so that could still be it. And this is a -2, which is concave down. So this could be our equation. I would use that one to verify. This is our standard form, and you have to be able to identify them. So this is in the form ax squared plus bx plus c. That gives us our y-intercept. So we've got our y-intercept at 0, -6. And so -6 would be somewhere here, depending on what the scale is. That is possible, that's the equation. And then this has a negative, so it's concave down, so that could work as well. Now, when we look at this third form, this is the factored form. It does have 2 negative roots, so that would work, but this is concave up. So this could not work. Same thing with this next one. This is concave up because of the a value. Cannot be this one. This is concave up. Cannot be this one. All right, this one is concave down because we've got the negative. It is written in the vertex form. And so our vertex here would be 6 and 3. Remember that minus is part of the formula. So with a vertex of 6, 3, well, 6, 3 is in the first quadrant over here. So we know that it's not this one. So that could not be the equation either. So that helps you eliminate a lot of choices so that you're only focused on the ones that are possible. We'll look at one more here. This one is a concave up parabola, so I can easily take out anything that has a negative. So both of these right here have negative ones, so I know it cannot be those. The next thing I want to look at is the different types of equations. So this is a vertex one. So my vertex is at 75, negative 92. So that h and k, and again, this is part of the formula, so that is not negative 75, it is positive 75. 75 and negative 92. That could work. That's in the third quadrant. We don't know what the scale is here, so that could work. So this could be one of the answers. This one here is the factored form. So my roots are 8, 0, because the minus is part of the formula, and negative 2, 0. Both of these are in a positive values. So negative roots would be over here on the x-axis, not on this positive side. So that can't work. This one is up and it's got a y-intercept of 240. It could, it depends on what the scale is here, but that's a possibility. This one right here is in the standard form. It gives us our y-intercept. In this case, that's 0, negative 2, because the c value is your y-intercept. That would be in the negative, and this is definitely a positive y-intercept, so that would not work. So that just shows you how to eliminate some of the answer choices, really thinking through what these formulas are and what they are giving you.